You're probably sick of this by now. You're like, I've gone far enough down the rabbit hole, haven't I? Just before, literally, just before I walked into roll call, I had another flash of insight, so I'm just going to share it with you. And if you're bored of it, then tough. I'm the teacher, so I get to make you do what I want. Okay, now I was trying to think, alright, I explained this, I was happy with it, right? Because I'm doing a similar kind of thing. But I was like, this is not a trig function. Why? I mean, this problem we're solving is kind of different, isn't it? Okay. So then I realized there is a problem. Here's what we've got. I'm trying to solve this, like so, right? And what I did was I took this thing in this form, and then I squared it. Okay. So let me do that. Let me show you what that looks like without doing the substitution. All right. So this is the original one. No changes, no squaring, no identities. Okay. That's one question. If I'd solved that, I'd be okay. But then I changed it. I said, look, let's change it into this. Minus 2 sine x plus 1. And on the right-hand side, I should have cos squared x, right? Okay, now we already expect that these two things are different. When you square, there's a problem. Okay. My question is, why is this so much of a problem? What's the issue? Okay. Now, I'm going to try and bring in an identity to explain it. Cos squared x. Cos squared x. Cos squared x has something to do with the double angle formula you learned last year. Do you remember that? Because you can write, say, cos 2x. Right? Cos 2x. You can write that as cos squared minus sine squared. But you can also write that as cos squared minus 1 minus cos squared. So I can write it like so. Is that okay? So here's what's going on. Okay, you compare these two functions, right? The period of sine is 2 pi. The period of cos is 2 pi. But when you square everything, the period is no longer 2 pi, right? What's the period of this thing? It's just pi, isn't it? So in other words, instead of doing this, okay, so that's why you get 3 points of intersection, you're going to get more of them squeezed into a smaller space. It's wiggling up and down more times. So in other words, it wiggles around more times, so it's got more opportunities to hit the other graph. That's what more solutions are. Okay? So if you have a look at this, what does that look like? Sine x minus 1. Let's see here. Everything's shifted down. So from 0 to... Okay, so it looks like this, right? That's sine x minus 1. And negative cos x. Cos x looks like that, so I'm flipping upside down. Okay, so it should look like this. Okay, can you see the three solutions? Can you see them? 0, pi on 2, and 2 pi. Okay, but then if I graph this, and what does it look like? It's quite different because the cosine graph wiggles more times. So, and this guy sine squared minus 1. Okay, I'm going to screw this up when I draw it. But if I think about sine x minus 1 squared, I'm squaring this thing. Okay, so minus 1 squared should give me 1. 0 squared should give me 0. And that's here. There's minus 1 again, so it's going to come up to 1. This one will be minus 2, so when I square it, it becomes like 4, right? And then you should come back to minus 1, square it, you should get 1. So you get something like this. Uh-oh, this is going to turn out bad for me. I'm going to go to there, don't I? Something like that. That's really awful. Get your computer out and do a better job. But, can you see? 1, 2, 3, 4 solutions. Okay, so it was close enough, right? So, I don't know how your brain's going at the moment. When I saw this, I was like, oh, that's why. Because I don't know if you're like me, you're like, this method seems okay. Why can't I use it? I like it. Don't tell me it's bad. Don't tell me that one part of it is bad and the rest of it is okay. Like, it's just so random and arbitrary. Why is it? Well, here is why. Okay, so always be wary. I mean, it's the same when you're solving inequalities, right? You can't just square everything and it'll be okay. All right. That's why we learn t-results. That's why we learn auxiliary angle. Okay. Thank you.